Hello. In this video, I'm going to be going over the beginning part of your 10.2 notes on arcs and chords. Right now we're going to be mostly looking at arcs, and I would like you to, if necessary, pause the video and draw in what I have for diagrams A, B, the two diagrams for C, and then D and E. You do not need to have printed out the notes, the 10.2 notes. You could just draw those diagrams in your notebook and that would be fine, and also have a highlighter ready. So I'm just going to pause for a second. All right, so let's start going through these. In a plane, letter A, in a plane, an angle whose vertex is the center of a circle is the central angle of the circle. So the central angle is just the angle in the center. It's the central angle, and we know a lot about angles. We've done them way back at the beginning of the year. So this is just angle APB. This is different than an arc. So in letter B, if the measure of a central angle, angle APB, is less than 180 degrees, then A and B and the points of circle P in the interior of angle APB form a minor arc of the circle. So a minor arc is going to be less than 180. So if it's less than 180, it's a minor arc. And so that's going to be going around on the outside of the circle, and we have special notation for that. So this is going to be arc AB. So I always like to say to students at the beginning of the year that if you have a segment above something like AB, that means something different. So at the beginning of the year, we said AB is a segment with just kind of the endpoints going in each direction, but we don't put points there. This is a line, and then this is a ray. But remember, AB with the arrow going nowhere is not a notation that we use at all. And now this is a whole new notation. So this is called arc AB, and that's how you would actually say that. So this is pronounced arc AB. All right, and when it is a minor arc between 0 and 180, you only use two letters to name it. It's a little bit different if it's a major arc or a semicircle, and that's what I'm talking about here for letter C. In letter C, the points A and B and the points of circle P in the exterior of angle APB form a major arc of the circle. So this is a major arc of the circle. If the endpoints of an arc are the endpoints of a diameter, then the arc is a semicircle, and that's the kind of part B to letter C. So for over here, we're looking at this arc here. So I'm actually, what if I went the other way and I'm not between 0 and 180 and I'm between 180 and 360? Now that's called a major arc. And this kind of tells you the direction that you're going. So back here, we went the shortest route from A to B. Now we're going to take the scenic route, and I'm going to call this arc ACB. I also could have called that arc BCA, and it would have been the same thing. Okay, but that's telling me the direction. It's saying I'm starting at point A, I'm going to go through C all the way to B, or I'm going to start at B, go through C all the way to A. And now here in letter C, we're looking at like the second part of letter C, we're looking at the semicircle, and that is because line segment AB is a diameter. So when you look at arc ACB, this equals 180 degrees, which is half of the 360. Okay, and I've started to get a little bit into degree, even though this is just kind of defining what they are. In letter D, we start talking about the measure of a minor arc is defined to be the measure of its central angle. And then in letter E, the measure of a major arc is defined as the difference between 360 and the measure of its associated minor arc. So this is the difference. So this means you'd be subtracting. All right, so let's say the minor arc is the measure of the central angle. So let's say that right here I have 160 degree angles. So that means the measure of angle ABC equals 160. degrees. Okay, now I know, and I'm going to put that little M in front. So even back here, I could have put the M in front, but the measure of arc AC equals 160 degrees, and I probably should, but right now I'm just kind of naming it. So maybe underneath I should write the measure of angle arc ABC equals 180, and then I'm going to erase that just so it's not confusing to you. All right, and so if this is 160, I would do 360 minus 160, and that's a pretty easy calculation. 3 minus 1 is 2, and then everything else cancels. So now the measure of arc ADC, that's the major arc, equals the 200 degrees. And I could have said this is the measure of arc CA, and I could have said that this is the measure of arc CDA, and they would be the same. In letter F, two arcs of the same circle or congruent circles are congruent arcs if they have the same measure. So that just kind of makes sense. So if you look here, you might want to pause it and draw in the diagrams for F and G. You have a doggy with one G, not two G's. Excuse me, you can't have a duplicate letter and a duck. All right, so all I'm saying here is if arc DO is 50 degrees and arc IE is 50 degrees. So the arc has a degree on the outside and the central angle has a degree on the inside. So they just kind of correspond with one another. So even back here, here is my central angle, and then here's my minor arc, and then this is a major arc. So here's the 180, and then here's the 200, and then all together they add up to 360. That's going to be the pattern. Even in the middle, this would be angle, this angle here would be 160 degrees, and then this angle here, if you did the other angle would be 200 degrees. And then down here, this is just saying that the measure of arc DO equals the measure of arc IE. So this is just talking about congruency, which makes a lot of sense. Okay. All right. And then the last one is arc addition postulate. This is a really useful postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So let's say that this angle here is 105 degrees. So this central angle would be 105. The corresponding arc is 105 degrees. I marked it as the arc. And now over here, this arc here is 100 degrees. The corresponding central angle would also be 100 degrees. And I'm going to write it out fancy, and I'm going to say the measure of arc DK plus the measure of arc, I don't want an equal sign, the measure of arc KC would equal the measure of arc DKC. Now, I'm not going to be asking you to write out the notation. I just want you to recognize that that's what you're doing. So you're adding this degree to that degree to get the total. So in our case, it's just 100 plus 105 to get 205 degrees. So this is kind of the introduction to arcs, minor arcs, major arcs, semicircles. A minor arc is between 0 and 180 degrees. A major arc is between 180 and 360 degrees, and a semicircle equals 180 degrees exactly.